Let us start our session about real numbers. The objective of this session is to understand Euclid's division lemma, understand fundamental theorem of arithmetic, prove irrational numbers, understand decimal expansion of real numbers. Before moving into the current topic, let us recall some of the concepts learnt in your earlier classes. What do you observe? These are numbers. These are positive numbers. These are negative numbers. Now look at the number line. It consists of numbers, which can be extended further to infinite numbers. In this number line, these are positive numbers, that is, the numbers present on right side of 0. And these are negative numbers, that is, the numbers present on left side of 0. Here, these positive numbers are greater, and these negative numbers are smaller. So, numbers on the left side are smaller than the numbers on the right side. Let us check our understanding. Hey, my number has more value than yours. So, I am larger than you. No. My number is larger than yours, because my number is at the right side of yours on the number line. Who is correct? As we discussed, the right side numbers are always greater than the left side numbers on the number line. You are absolutely right. As you said, the right side of numbers is always greater than the left side numbers on the number line. So we can classify the numbers into positive numbers and negative numbers. Is there any other classification? Imagine that you are moving along a number line towards right side of it. As far as you move, you would observe that there are only numbers on number line. By observing numbers on a number line, you started collecting some of the numbers. You might begin with collecting only numbers like 1, 2, 3, 4, and so on. These numbers are called natural numbers. Let's define, what do you mean by the natural numbers? Natural numbers. The numbers 1, 2, 3, 4, 5 and so on are called natural numbers. Natural numbers are denoted by the letter n. So, we have n equals 1, 2, 3, 4, 5, 6, 7 and so on. Let us look the natural numbers on number line. Now you turn and move all the way back, collect 0 and keep it with natural numbers. Now you have the collection of numbers like 0, 1, 2, 3, 4, 5, 6 and so on. This collection of numbers is called whole numbers. Let's define, what do you mean by whole numbers? Whole numbers. If we include 0 to the set of natural numbers, n, a new set is obtained, which are called a set of whole numbers. Whole numbers are denoted by the letter w. So, we have w equals 0, 1, 2, 3, 4, 5, 6 and so on. We can say that w equals 0 union natural numbers. Let us look whole numbers on number line. Now you are at 0, move forward towards left of number line. Here, you can observe many negative numbers. Collect all the negative numbers, and keep them with whole numbers. Now, you have the collection of numbers like 0, 1, 2, 3, 4, 5, 6, and so on. And, -1, -2, -3, -4, -5, and so on, which are called integers. Let's define what do you mean by integers. Integers. The set of numbers, consisting of the positive numbers, 0, and negative numbers are called the set of integers. Integers are denoted by the letter Z. Z comes from the German word zählen, which means to count. So, we can say z equals, and so on, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. Let us look the integers on number line. Do you think still you have left some numbers on the numbers line? Yes. There are numbers like 1 by 4, 3 by 2, or even -2002 by 2001, or some other numbers. You keep all such numbers with integers. It will now be the collection of rational numbers. So let's define, what do you mean by rational numbers? A number is said to be rational number if it can be written in the form p by q, where p and q are integers and q is not equal to 0. Rational numbers are denoted by the letter q. For example, take -15. -15 can be written in the form of -15 by 1. Here, p equals -15 and q equals 1, where p and q both are integers. So we can say that all integers are rational numbers. Now, let's consider following numbers of the form p by q. 4 by 8 can be written in the form of 1 by 2, so 4 by 8 is equal to 1 by 2. 16 by 32 can be written as 4 by 8, which can be written as 1 by 2. Similarly, 100 by 200 is equivalent to 16 by 32, is equivalent to 4 by 8, is equivalent to 1 by 2, and so on. Such numbers are called equivalent rational numbers. Here, we notice that the above rational numbers do not have a unique representation in the form p by q, where p and q are integers and q is not equal to 0. Thus, the rational numbers also include the natural numbers, whole numbers, and integers which are shown in the figure. And also, there may be numbers on number line, which are not rational numbers. Up to now, all the numbers you have come across are of the form p by q, where p and q are integers and q is not equal to 0. Do you think, are there any numbers which are not in the form p by q? Yes, there are numbers which are not in the form p by q.